So the next topic here now is fundamental and derived units. Fundamental and derived units. So when you talk about from measurement, units of measurement are divided into two. The first is what? The fundamental units. Is the fundamental unit. And the next is what? Derived unit. So when we say fundamental units, what are we talking about? Fundamental units, in my previous introduction, I talked about physics is all about that in physics that you should be able to measure, that if you can't measure anything, then you can't control that thing. Then in the course of doing these measurements, there are some physical quantities. There are some physical quantities that you cannot just get them by any kind by ordinary analysis or just by beginning to combine things or theory. There are units that you have to do measurements to get their actual value. That's what we call fundamental unit. That's units that really need measurement for things to work out, for you to be able to determine magnitude and size. It's not, when you talk about fundamental, it's not unit that you can use a particular formula or you begin to mix things to get them. There are units that necessitate measurement. You understand? So you don't call it fundamental, you can call them basic units of physics. You understand? So these basic units, the first one is length. Of course, what is length? When you talk about length is just when you talk about length is a measure of distance between two separate or distinct points. Like if you say between this point and this point, the distance between this point is a length. You understand? It's a measure of distance between two distinct points. So length is the first fundamental quantity in which it should be measured. It's usually measured. It has its instrument of measurement, in which we'll still talk in the next series of the videos. And then the unit for measuring length is in meter. The symbol or the letter for meter is small letter m, not capital letter M, small letter m. Now the next fundamental unit is mass. Mass is a necessary quantity or unit that has to be measured. And the unit for measuring mass is kilogram. kg. The next one is time. And by the way, the definition of mass is the quantity of matter contained in a body. It's not weight. Mass is what? The quantity of matter that you can get from a body, not the weight. Okay? So time. Time simply measures the duration between two events. Take, for instance, life itself depends on time. Everything about life works with time. Time to be a boy or a baby, time to be a teenager, time to be an adult, time to be old, and time to die. So time is one parameter or quantity that finds itself in every aspect of life. In fact, life itself is time. Okay, time brings about existence. So time is a very fundamental quantity. You cannot hardly you see calculations that do not involve time. Okay. All right. So the unit for measuring time is seconds. The unit for measuring time is seconds. And the symbol is small letter s. So these are the main three ones that are very necessary. And then the next one that is also taken in consideration, well, is what? Current, electric current. Electric current. Electric current is measured in ampere. The symbol for ampere is capital letter A. That's the unit for measuring what? Electric current. So the next one we're going to look at, but these four are the main basic fundamental quantities. Other ones are just, kind of complete the circles. Next one is amount of substance. Amount of what? Substance. What's the unit for measuring amount of substance? Mole. Then number six, fundamental quantity is a temperature. You know that temperature plays a very critical role because it's through manipulation of temperature we are able to cook meals, do chemical reactions, do a lot of things. So temperature is a very fundamental, and it needs measurement, and it has its equipment for measuring. So the unit for measuring temperature is Kelvin. And the symbol for Kelvin is small letter K. And the last one we'll look at is luminous intensity. Luminous what? Intensity. Measured in what? Candela. When you talk about luminous intensity, that's you are talking about the amount of illumination you get from light, the amount of light energy you get. You understand? Because light energy is usually measured as well. So when you talk about luminous intensity, you're talking about amount of light energy you can get from any lighting substance or illuminating substance. So it's measured in candela, and the symbol is small letter C and small letter D. So these are what? Fundamental units. Any other thing that is not here, any other unit or quantity that is not here is called a derived unit. When we say derived unit, that means we are combining these fundamental units, because when you say derived units, those ones, derived units most times don't necessitate measurement. You understand? Because once you're able to measure some of the fundamental quantities of any of a thing, you can be able to get their magnitude in the derived form, or you can be able to get you'll be able to get the magnitude of their derived quantities. So derived quantities are a combination of fundamental quantities. Take, for instance, when you say area. Area is a derived quantity. And area is combination of length. A length times another length. Usually it's a length times breadth, but breadth itself is also a length. Understand? So when you combine two lengths, multiply two lengths, you get area. So you see, and when you say area, we don't necessarily need an equipment to begin to measure area of anything. All we need to measure is what? Length. We measure length of the first side, we measure the breadth. Then we do calculation and get area. But when you talk about length, that one necessitates measurement. But area, do you really need to bring an equipment to measure? No, that's why it's a derived unit. Because you can directly, once you're able to measure the fundamental unit of it, which is length, you can calculate and get area. So area is a derived unit. Same with volume. Volume is what? A derived unit. Volume is when you measure three lengths. So it's a length times another length times another length. But usually we say length times breadth times height. But all of them are usually what? Length. So length times length here is meter squared. That's the unit for area. And unit for volume is meter cubed. So you see, volume is a derived unit. Once you're able to measure the three lengths of any vessel, or any body, you can calculate the volume. You don't need to begin to do, you understand? Same with when you talk about speed. Speed is a derived quantity with a derived unit. Why? Because speed is what? Distance over time. The number of distance you've covered related to time. And we know that distance is the same thing as length. Understand? So, and you see, time is a fundamental quantity, distance is a fundamental quantity. So you combine them, it gives you a derived unit. And the unit for distance is meter. The unit for time is seconds. So the unit for speed will be what? Meter over seconds. Or you say meter per seconds. So you see, is when you combine all these fundamental unit, you're able to get derived unit. The same thing as when you talk about velocity or pressure, or when you talk about force. Force is a derived unit because force is what? Mass, which is a fundamental unit, times acceleration. And you know acceleration on its own. Acceleration on its own is what? Velocity over time. And velocity is what? Displacement over time, then divided by time. So you see, for acceleration, it makes use of a length, distance, which is a fundamental quantity, makes use of two time. Understand? So you combine to give you force. So those are derived units. And you see that some of these derived units, most times we don't need instruments to measure them. Once we are able to measure their fundamental part of it, we are able to calculate the derived quantities. So that's it about fundamental and derived quantities.